Okay, so types of stress. The stress may be normal or a shear stress. Normal stress is the stress which acts in the direction perpendicular to the area. It is represented by sigma. The normal stress is further divided into tensile and compressive. Okay, so what is tensile stress? The stresses induced in the body when subjected to two equal and opposite pulls, as a result of which there is an increase in length, is known as tensile stress. The ratio of increase in the length to the original length is called tensile strain. The tensile stress acts normal to the area and it pulls on the area. Okay, increase in L pulse acts normal to the cross sectional area, delta L upon L, increased length upon the original length. Okay, next is the formula. Formula is written here. We'll see. Okay, so this bar is getting pulled. This bar is getting pulled by a load P from both the sides. So there is a resisting force that is happening on the section XX, and there is within the elastic limit P is equal to P is directly proportional to the R. So sigma is equal to P by A as resisting force upon the cross sectional area. So tensile stress would be sigma is equal to P by A, and tensile strain would be dl upon L. With whatever the changes happening in the length, increase in the length would be the dl, and L is the original length. Okay, that is cleared. Remember that normal stress always happens perpendicular to the surface, perpendicular to the cross sectional area. Okay, normal stress, we have two type of tensile stress and compressive stress. So that is cleared. Now we'll move to the compressive stress. The stress induced in a body when subjected to two equal and opposite pushes. Okay, tensile stress means two equal and opposite pulls, and compressive stress is two equal and opposite pushes. Okay, as a result of which there is a decrease in length of the body is known as compressive stress, and the ratio of the decrease in the length to the original length is known as compressive strain. The compressive stress acts normal to the area and it pushes on the area. That is cleared. Okay, now this bar is pushed. Okay, and the excess on the XX section, we are getting the resisting force. So resisting force will be proportional to the P, which is it will be equal in the within the elastic limit. So here compressive stress formula will be the same as tensile stress. So sigma is equal to P by A. That is easy to remember. Okay, and compressive strain is represented by E, small e, which is dl by L. Now moving to the shear stress. Shear stress is the stress induced in a body when subjected to two equal and opposite forces which are acting tangentially across the resisting section. So remember, tensile stress always acts perpendicular. Shear stress always acts tangential across the resisting section. As a result, which the body tends to shear off across the section is known as shear stress. The corresponding strain is known as shear strain. Whatever the corresponding strain occurred because of this stress is known as shear strain. The shear stress is the stress which acts tangential to the area. It is represented by tau. Okay. Now we'll see this in the next video. Okay, so thank you. Please like, share and subscribe to my channel, and that's it.